Good day, everyone. This is Glenda Postrado from BS EdMod 2A, and I am assigned to answer 2.4, number 25. Factor the matrix A into a product of elementary matrices, where A is equal to 1, 2, 1, 0. So we have matrix, elementary row operation, and elementary matrix, where matrix is defined as a set of numbers arranged in rows and columns to form a rectangular array. And elementary row operation refers to simple operations that allow to transform a system of linear equations into an equivalent system. That is, into a new system of equations having the same solutions as the original system. And elementary matrix is defined as a matrix which differs from the identity matrix by one single elementary row operation. Let's start. Under the matrix, we have the given matrix 1, 2, 1, 0. And under the elementary matrix, we have the identity matrix. So let us now perform the first elementary row operation. Row 2 plus negative 1 multiplied by row 1 to form the new row 2. So this is our row 1 and this is our row 2. So 1, 2, 1 plus negative 1 multiplied by 1 and 0 plus negative 1 multiplied by 2 equals 1, 2, 0, negative 2 with our newly formed row 2. Next is, we will find the first elementary matrix using the same elementary row operation that we use. So this is our row 1 and this is our row 2. So 1, 0, 0 plus negative 1 multiplied by 1 and 1 plus negative 1 multiplied by 0 equals 1, 0, negative 1, 1 with our newly formed row 2. So this is our first elementary matrix. Next is add row 1 to row 2 to form the new row 1. So this is our row 1 and this is our row 2. So 1 plus 0, 2 plus negative 2, 0, negative 2 equals 1, 0, 0, negative 2 with our newly formed row 1. Next is, we will find the second elementary matrix by performing the second elementary row operation into identity matrix. Why? Like what I've said earlier, an elementary matrix is a matrix which differs from the identity matrix by one single elementary row operation. So this is our row 1 and this is our row 2. So 1 plus 0, 0 plus 1, 0, 1 equals 1, 1, 0, 1 with our newly formed row 1. So this is our second elementary matrix. Lastly, multiply negative 1 half by row 2 to form the new row 2. So this is our row 2. 1, 0, negative 1 half multiplied by 0, and negative 1 half multiplied by negative 2 equals 1, 0, 0, 1, or the identity matrix with our newly formed row 2. Next is, we will find the third elementary matrix by performing the same elementary row operation. So this is our row 2. 1, 0, negative 1 half multiplied by 0, and negative 1 half multiplied by 1 equals 1, 0, 0, negative 1 half with our newly formed row 2. So this is our third elementary matrix. So we now have our matrix, elementary row operation, and elementary matrices. And because elementary matrix 1, elementary matrix 2, elementary matrix 3 and matrix A are equal to identity square 2 by 2 matrix, we factor A as follows. A is equal to E sub 1 inverse multiplied by E sub 2 inverse multiplied by E sub 3 inverse. In finding the inverse of a 2 by 2 matrix, we use this formula. A inverse is equal to 1 over A multiplied by D minus B multiplied by C multiplied by the matrix D, negative B, negative C, and A. For instance, our 2 by 2 matrix is in the form like this. So x sub 11 is our A, x sub 12 is equal to B, x sub 21 is equal to C, and x sub 22 is our D. Let's start. So E sub 1 is equal to 1, 0, negative 1, 1. To find E sub 1 inverse, we use this formula. E sub 1 inverse is equal to 1 over A multiplied by D minus B multiplied by C multiplied by the matrix D, negative B, negative C, and A. Substitute the given. E sub 1 inverse is equal to 1 over 1 multiplied by 1 minus 0 multiplied by negative 1 multiplied by the matrix 1, 0, 1, 1 equals 1 over 1 or 1 multiplied by the matrix 1, 0, 1, 1. So E sub 1 inverse is equal to 1, 0, 1, 1. Next is E sub 2 is equal to 1, 1, 0, 1. Using the same formula, E sub 2 inverse is equal to 1 over 1 multiplied by 1 minus 1 multiplied by 0 multiplied by the matrix 1, negative 1, 0, 1 equals 1 over 1 or 1 multiplied by 1, negative 1, 0, 1. So E sub 2 inverse is equal to 1, negative 1, 0, 1. Next, E sub 3 is equal to 1, 0, 0, negative 1 half. So using the same formula, we get E sub 3 inverse is equal to 1 over 1 multiplied by negative 1 half minus 0 multiplied by 0 multiplied by the matrix negative 1 half 0, 0, 1 equals 1 over negative 1 half or negative 2 multiplied by negative 1 half 0, 0, 1. So E sub 3 inverse is equal to 1, 0, 0, negative 2. So, we factored the matrix A, which is equal to 1, 2, 1, 0 by A is equal to E sub 1 inverse multiplied by E sub 2 inverse multiplied by E sub 3 inverse. Or A is equal to 1, 0, 1, 1 multiplied by 1, negative 1, 0, 1 multiplied by 1, 0, 0, negative 2. Thank you.